just to echo the words of all the other speakers, it's just such a pleasure to be physically present with you all and to see all of you are getting out of bed on a Saturday morning. My children are roughly your age, and no way they will be out of bed at this time. So very grateful for you making the effort. My title is called I Wonder What I'll Be When I Grow Up. And I was talking to Rochelle Bookbinder before, who indeed was my registrar when I was a junior resident, despite which I became a rheumatologist. I was telling her that I loved the fact that she had the word serendipity in her title, and the ENT surgeon who spoke earlier spoke about basically walking across the road and ending up talking to somebody. And I think it's so important to be curious and not plan too much. That is my message. I could probably just stop now, but I'll tell you about my life and how I never had a plan and still don't. These are my disclosures. So here's the summary. Research is great. It's fun. It makes a difference. It's how we live, right? We're surrounded by science, engineering. There's electricity powering the lights. You're all got your devices in your pockets. It all happens because of science. So we have to think about what we're here for as clinicians, which is to make people better. And if there wasn't for science, we'd still be treating people the same as we did in the days of Hippocrates. And we're not. And the difference is science. But even though I'll tell you that I love it, I do want to keep telling you, you don't really need to have a plan. I did watch some of the videos that are available on the website, and very inspiring videos, but I don't agree with some of the speakers there who actually exhort you to start building your networks, make your connections now, plan your next step, etc. Yeah, nah, don't bother. We all try to sell each other ourselves, right? I want to tell you that I've had a great life because it makes me feel like I have. And someone who's a full-time practitioner who's never done research will tell you, I've had a great life. You could do that. They're all right, okay? I'm going to tell you don't plan. I'm right. Someone else will tell you to go and plan. They're also right and wrong. And we're all right and wrong in the same degree. So my story. So I grew up just a couple of kilometres from here, actually, in a suburb that I think is now called Wheelers Hill. It was called Mulgrave at the time. And I went to Brentwood High School. And I was very lucky. Something momentous happened to me, which is that the teachers there suggested that I apply to go to Melbourne High. And I didn't want to because I had all my friends. I was 13 or whatever. And anyway, my arm was twisted to go for a year with a deal that I could go back to my old high school if I hated it. And then what I just found out was something that stuck with me forever, which is that you're better off to be surrounded by people, all of whom are smarter than you, which is what happened when I went from my local high school to Melbourne High, which is a selective entry high school. And everything I did was with people who are better at it than me. And I've tried to keep everything like that since then. So I chose 4 science subjects for year 12. Why? Because I had no idea what I wanted to do, no plan. So I actually literally looked at the entry criteria for all the courses. What closes the fewest doors? That's why I chose those subjects, no other reason. I want to keep my options open. Something else happened to me at Melbourne High that has changed my life, which is that everybody had to sing and everybody had the opportunity to learn a musical instrument. And so I did. So Monash University, I got into med school. I will make a confession that I've never made in public before. Why did I become a doctor? Because I got the marks. I had offers to do naval architecture, fabric design. Both of those sounded pretty interesting to me, actually. I had no clue, no plan. But I got the marks to get into medicine. My plan actually was to exit halfway through. In those days, you could exit, as you could now in a Monash degree, be a med-sci, graduate with that, go and work in a lab somewhere and play music. That was my plan. But I forgot to leave, basically. I literally just didn't get around to exiting. So I finished med school. And then I did my internship at Prince Henry's, building and hospital which no longer exists, now the Melburnian Apartments, which because I'm an academic non-procedural clinician, I can't afford to live there. My plan was definitely to never be a specialist, never do research, and definitely not do administration. That's what I did. But my plan was to play music. So I completed my physician's basic training and 1 year of advanced training in rheumatology. And the mentors and professors around the place saying, here's what you've got to do. You've got to finish your advanced training, and then you've got to do a PhD, and then you've got to go overseas. And I said, yeah. So I didn't. I decided to do my second year of training away from home when I went to Bath, the home of the Royal National Hospital for Rheumatic Diseases, founded in 1738. That's the building that it was in until a couple of years ago. It's now been converted to a luxury hotel. The real estate's simply too precious to be owned by the NHS. And the Royal National Hospital for Rheumatic Diseases is in Bath because of the hot springs that were discovered by the Romans when they ran England. And these are the actual Roman baths that have been excavated, not a facsimile. And in the basement of this building, there's an excavation. There's a Roman tiling that you can walk on. So it's an amazing place. And it also has 2 music colleges. But I went there by accident. It had no plan. It just so happened that the year before, the guest speaker at the Australian conference when I was a registrar was a professor from Bath. So I met him and we got talking. That's why I went to Bath. There was no plan. So here's what we were looking at in the 1990s. Rheumatoid arthritis is still a terrible disease if untreated. And in those days, basically, we were using drugs that didn't work. And outcomes were terrible: deformities, nodules, extra-articular features, vasculitis. And this is a paper from 1994 of effects of different variables on patient outcome. And the outcome is death. The outcome that was being measured in the early 90s in rheumatology was death from rheumatoid arthritis. Things were going very badly, and radical change was needed. So it was kind of an exciting time to be thinking about going to research in rheumatology, because recognition that everything we were doing was terrible had happened, and we needed to do everything different. And around the same time as well, there was a small scientific revolution led by a couple of guys from San Diego, one of whom I subsequently met. The prevailing dogma in immunology at the time was that T cells are the conductors of the orchestra and everybody else is just following orders. Macrophages, etc., don't worry about it. These folks disagreed. They found that the abundant cells in the actual inflamed tissue were actually macrophages, producing macrophage products like TNF. And anti-TNF drugs were first trialed in humans in 1993. And this was the first big breakthrough proving that that rheumatoid arthritis could be addressed through a scientific approach. And these folks got a lot of the same hate mail that Rochelle got. It was gigantically controversial, this push to start looking at macrophages. We have pretty small lives, right? Academic rheumatologists, this was controversial and people had fights about it. But anyway, the rest is history, as they say. So I was a clinician, I was a registrar in Bath, and I wanted to stay another year. Things were interesting. I didn't really feel like coming home, and I was enjoying playing music when I was there. So I needed 1 more year to get my FRACP. I thought, oh, what the heck? I'll do a year of research just to fill in time. So lesson 1, just do it. Whatever door is open, why not walk through? So into the lab I went. Oh, here's a funny story. So this is an ancient flow cytometer, which is used to measure the cell surface expression of proteins labeled with antibodies. And the hospital, the research center that I was going into, had just received in 1991 their first flow cytometer. And that's called a fluorescence activated cell sorter, FACS. It's pronounced a fax machine. Now, the professor who met me when I got to Bath said, "We're very excited, Eric, we've just got our first fax machine." And I sort of went, oh, yeah, I know, because it is exciting, isn't it? Because I've been able to send my letters over to you via the fax machine in order to be here today. And he just looked at me and said, what the hell have we got ourselves into here? So embarrassing. Okay, I was just so certain that this was not going to be my life. A question was asked before about, is it hard to learn in the lab when you've been a clinician? Oh, yeah, it really is. And don't the lab people let you know as well? Oh, boy, do they ever. You know, which end of a pipette is up? You haven't got a clue. How to do dilutions, flat bottom plates, round bottom plates, alien universe. But we're quick studies often, us medical graduates, so you can pick things up. And I had an experience, some beautiful mentors here who taught me some great things, one of which was a year in the lab saves an hour in the library. And another which was, if you can understand what your postdoc is talking about, get rid of them. In other words, surround yourself with people who are much smarter than you. But I had one other great experience here with one of the scientists, a PhD graduate, who was giving us medics in the lab a very hard time. At the tea break, she was studying bone cells, and I said, "Oh, what are you doing today?" So I'm, putting some IL-6 and some dexamethasone on the osteoblast to see what happens. And I said, "Oh yeah, cool. Steroids, osteoporosis, cool." And she said, "What?" I said, "Steroids, osteoporosis." "What do you mean?" "Dexamethasone, bone cells, steroids, osteoporosis. That's what you're doing, right?" She said, "Really?" She starts taking notes as I'm talking. So I thought, okay, maybe I have got something to offer to this equation. So this was my first paper from my time there, and like a lot of my work since then, it has focused on using the lab to measure things in people. Rather than starting in the mouse and then seeing if it's true in the human, start in the human and use other techniques to find out whether what you're doing is real. This was on a glucocorticoid-induced protein called lipocortin-1, at that time now called annexin-1. And I've studied glucocorticoids ever since. There was no plan. That's just what the person I was working with was doing. So I've done it ever since. No plan. So I was planning to get the hell out of there because I knew that research was not for me, but something happened. So one of the things I had to do was do some immunostaining on some human rheumatoid arthritis tissue to see whether this lipocortin-1 protein was present in the joint. So somebody taught me how to do immunohistochemistry. We cut the sections, we stained them. I looked down the microscope, and the journal photo was black and white because it was cheaper, but the color was actually red. I looked down the microscope and there was red, meaning that lipocortin-1 is in the rheumatoid arthritis synovium. And no one had ever seen that before. Now, I didn't invent it. It was always there. But I was looking down the microscope, realizing that I was the first person to see that. And I really liked it. I really liked how that felt. So I discovered basically that I really my inner nerd was stimulated by the discovery of new facts. So I was hooked. So all of that happened without a plan. Realizing that I did want to have research in my life, I thought, okay, there are some things I better do. Rochelle was talking before about doing a PhD so that you can do certain things. So I decided to come back to Melbourne and do a PhD in the same place that I still work now, at Monash University. And I decided to keep on working on glucocorticoids. As you know, there's a very good medical reason to do that because they work, but they're terrible. If we had a steroid without side effects, we would have an amazing therapy for human disease. And we're still working on it. We might be getting closer. So that's the work that I did in my PhD. And then because no one else was around, they asked me to start a research lab in rheumatology. And then I made one very good decision, which was to get a fantastic first PhD student. And those of you who are Monash graduates from the last few years will recognize Professor Michelle Leach, who's the head of the Monash medical degree. What you may not know is that she's actually a distinguished clinician-scientist from earlier in her career. She rejected the project that I gave her and started a different one, which was to look at this molecule called MIF in human rheumatoid arthritis. Same thing as I was trying to do, but in a different molecule. Many, many papers were published. This is one of them, where the method turned into the result. We wanted to look at synovial cells from the mice that were deficient in MIF. We wanted to grow them so we could do experiments on them. but we found that we couldn't grow them. They wouldn't grow, deficient in MIF. And we then tried to find out, why is that? And it took a couple of years, but we found out that this very important pro-apoptotic molecule, p53, was dysregulated in the absence of MIF. So here, the method turned into the result. And it was a very nice paper. So listen here is always listen to your younger colleagues. If you've been smart enough to surround yourself with people who are smarter than you. And the other lesson there is sometimes the result that's not the one you're looking for is much more interesting than the one that you were looking for. Always look for that. So having found that MIF was looked very important in rheumatoid arthritis, and Michelle's big paper that she got a plenary presentation at the American College of Rheumatology was blocking MIF with an antibody, and in rats with arthritis, no arthritis. It was a big effect. We thought we better do something about it. This is an ancient photograph of me. That's 20 plus years old with Magdi Iskander, a medicinal chemist, and Monash is an amazing place because of all the different departments that we have. He's a structure-based drug design person, and so we arranged to meet, and we thought, yeah, we'll give it a shot. So we got a crystal structure. His particular knack was designing molecules that would dock into protein structures. There are other ways to do this sort of work now, but that's what we did. We made thousands upon thousands of compounds. That's very expensive. We filed a patent, which was granted. We started a company called Cortical Proprietary Limited with venture capital investment, and which means we had to hire an artist to design a logo. Lots of fun. And Cortical did a deal with Genzyme, a big US biotech company. The date here, 2003, it was the biggest biotech deal in Australia that year. Yeah. You can do big things. Each of the speakers that you've heard from today have done big things. Many of them not particularly ever planning to start a company, definitely not me, but there was MIF. Somebody had to do it. Give it a shot. Where is Cortical now? Your search reveals no hits on the ASIC database. It all went away. We couldn't reach the potency required to take our compounds into human development. And year after year after year of trying to make that technical scientific leap, we were unable to do it. The company went away. It's very important not to take failure personally. If you decide to embark on research, you will fail a lot, okay? Because if you're not failing, you're not trying to do things that haven't been done before. So get ready to fail a lot. And you'll have to understand, you have to work out an arrangement with yourself for that to be okay. Took me a really long time, actually. I think I'm okay with it now. Okay. So the 20 years since I started in research until 10 years ago saw an incredible change in outcomes for people with rheumatoid arthritis. This is also a mortality graph for rheumatoid arthritis, but it shows the difference from the end of the last millennium up until 5 years ago. Look at that incredible improvement in death in patients with rheumatoid arthritis since all the treatment innovations that we had. Mortality now approaching the healthy population. But here's the same graph analysed by the same people using the same methods for lupus in the same time period. No change in mortality. Lupus mortality is actually quite a big problem. The 15-year survival is about 80%. That's not so great if you're 20, because that's a 20% chance of not making it past 35. And real people die. This is Kim, who died under my care at Monash of lupus. This is Amy, who died under my care of lupus at Monash. These are patients that I've known for many years. One of the great things about rheumatology is you have long-term relationships with people, and it's just not okay. It's not okay for these people to die. Someone has to do something about it. So let's always keep remembering why we're here, make a difference. You will have worked out by now that I'm a deeply arrogant person who believes he can do anything. So I decided that I wanted to do something about lupus. So we stopped working on rheumatoid arthritis, actually, completely, and switched to lupus. So the next few slides, we're going to show the amazing work of other people in the team in the last few years that have started to make a difference. So this is Kate and Kim, two rheumatology trainees who started PhDs, and I'm going to come back and show them again at the end because neither of them finished their PhDs. They just didn't like it. Kate is? Kate's going to do another one. Okay, she's found a better supervisor. We'll come back to it. That's controversial. Anyway, it's okay. If research is not for you, that's all right. No problem. Don't worry about it. One of the problems in lupus is it's very hard to measure treatment outcome. It's a complicated disease. Many organs are affected. Every patient is different. How do you measure improvement when that's the substrate? Actually, it's a solvable problem. It's just no one had really applied a proper scientific method to it before. I was actually a lab person from the rheumatoid space. Those things have been sorted out. And then lupus space, just no one had done it. So we just decided to do the work. So we decided to define treatment goals for SLE. And then Vera Golder took over this project. This is Vera giving her plenary presentation at the American College of Rheumatology in 2019 in Chicago. That's a photo of me with her, very proud, her paper in Lancet Rheumatology. And a bunch of us having great time celebrating that achievement. So we now have defined and validated in a very, very large cohort of patients a new outcome measure for lupus trials because we need to know whether the treatments work. Along the way, also the syncing is slightly out of order. This is Ai-Lee Yo giving her plenary presentation at the European conference. Her project is jointly supervised by myself and Michelle, along with Alberta Hoy and some other team members, looking at a redundant test ordering in the rheumatology space, also relating to lupus. This is Diana Apostolopoulos, who's just been granted her PhD. Her paper in Lancet Rheumatology was about measuring the harm that steroids do in patients with lupus, and it's really easy to measure that harm. This is Champa. Sorry, the photos come out a bit blurred. Champa is a rheumatologist who got her PhD. This is me and Sarah Jones, who's a PhD scientist who co-supervised her. Champa was from a small village in India. She was the first person in her village to finish high school, let alone university, and now she's got her PhD. She studied the molecular mechanisms of action of glucocorticoids, and we think that we might have some answers. This is Melissa Northcote, who was a BMed Sci student, now PhD student. Her paper looks at glucocorticoid-regulated genes in patients with lupus, and I just wanted one day to have a paper with a heat map in it, so now I think I'm one of the cool people. The reason I'm telling you about this is the greatest joy of my life is the joy that comes from the success of other people. So this is a beautiful book. It's a bestseller, actually, Julia Baird, Phosphorescence. One of her concepts she talks about is Freudenfreud. Schadenfreude is the joy at the suffering of others, okay? Freudenfreud is joy at the joy of others, and I commend it as a way to be. So I'll finish now by just talking about another person. This is Kat Connolly, who's an amazing person who's now a PhD student. When she was a med student, she looked at interferon-induced chemokines in the blood of patients with lupus. So type 1 interferon is a cytokine family involved in innate immunity and been known for quite some time to be overexpressed in lupus. Very hard to measure, and we measure it through surrogates, in this case, some chemokines. We did another project with people from the faculty of IT, data scientists, who came up with code to look at variability over time. And if you're a musician, you know that the whole orchestra has to play in 4/4 for it to make sense. If someone's playing in a different time signature, it's not going to align. But patients are not following a conductor or a metronome. They've got their own inner time sequence, and it's very hard to align them, but there are data analytic techniques that let you do that called dynamic time warping. And it makes my brain hurt every time I try to understand, let alone explain this. But basically what happens is you use this software to align variations that appear to be unaligned but are actually just playing at a different tempo. And so you snap them together and you can draw new analytic insights from that. So that was Kat looking at interferon as a therapeutic target. What she's doing her PhD on is still the problem of needing to improve outcome measures for lupus trials. Still a solvable problem, and we've decided that we're going to solve it. This is her editorial in Lancet Rheumatology from just a few weeks ago, outlining the issues that need to be addressed to solve that. So lesson 8 is say yes to things you haven't done before. One day, about 6 years ago, I got a phone call from some people that I've been talking about our work in measurement to from MedImmune, a US pharmaceutical company, saying they wanted me to be the principal investigator of a clinical trial. And I explained to them that I'd never done that before. And they said, that's kind of the point, is that all the other ones have failed. So we want people with fresh thinking. I thought, I can do that because I'm the person who thinks he can do anything. It's a kind of a delusion of grandeur mixed with willingness to take chances. So I'm very glad for that phone call and that I said yes, because actually this paper of the results of that trial is a positive trial of blocking type 1 interferon in patients with lupus. And the first country to approve this therapy was France, and that happened 2 days ago. So we might just have a blockbuster drug for lupus for the first time ever. And it's been a huge privilege for me to be part of a gigantic team helping make that happen. So that just happened because I said yes to things. Finally, I'm going to join with Rochelle, who talked about her swimming. Keep doing the things you love. You probably work hard. People say, what's your ratio of teaching, research, administration? I always say 100, 100, 100 ratio. But work-life balance is okay if you love your work. So the French philosopher Montaigne talks about this concept of always have a room behind the shop. So you have your work and you have your family and you have something else that you do that isn't work or family, but it's something that you do. Mine is music, as I keep alluding to. These are some extracts from the last year or two from my band, the Hornstars, which is currently doing pre-production for recording its second album. This was my previous band that had 2 albums out. These are some gig posters for my other band, currently Juicebox. We have another gig coming up in September. Feel free to Google it. I've never been able to stop doing that. So I encourage you to find your passion that isn't work and make sure that you keep going. So research is great. Planning is fine, I guess, but actually you don't need to. Just keep curious and walk through doors of opportunity. And then just one more thing. Actually, medicine is great. We are so lucky that we get to work in a profession where we get to help people all the time. This is a recent photo from of my team. Some of the people in here are clinician-scientists, and some of them are clinicians, and they're all having a great time. This is the photo I took from Chicago after Vera's plenary presentation. Half the rheumatologists in this photo don't do research. They're still having a great time. They're going to a conference, learning about how to help their patients and putting that into practice. That's also a great way to spend your life. And I'll finish by saying it actually doesn't matter what you are when you grow up, but it does matter who you are. So be good and be kind. That's it. Thanks.
Thank you, Eric, for a philosophical approach on life as a clinician scientist. We do have one question that popped up in the Slido that you alluded to not having a plan. How did you fall into rheumatology? What drew you to it?
What drew me to rheumatology was a combination of factors. You know, the rotations are handed out semi-random, and rheumatology was one of my rotations. I did have a very good registrar. At that time, most things that we did, we couldn't treat, but they were very interesting. Rheumatoid arthritis, what the heck is that? Now we know, actually. Lupus, we're still trying to solve. So curiosity, I guess I'm a curious person, and my curiosity was attracted to it. My other interest was actually cardiology. And at that time, stenting had just come in. And it was clear that if you're going to be a cardiologist, you would be getting up at night stenting people for the rest of your life. And I'll be honest, I didn't fancy it. So I chose rheumatology.